One of the more popular and common use cases that gained a lot of traction in 2021 were NFTs, or non-fungible tokens. NFTs can be used to tokenize real-world assets, such as tickets, songs, or mortgages and deeds to properties. In today's video, we're going to be going over the NFT standard, which is ERC 721, what makes up the standard, and how to actually implement and write your own NFT smart contract. My name's Anthony with the Blockchain Dojo, where we teach you how to become a blockchain ninja. If you learned something new, please like and subscribe, and stay tuned for more content. Let's get started. In order to first understand what an NFT is, we have to understand what the ERC 721 standard is. On the ethereum.org website, we're going to be going over the ERC 721 standard, which starts with the event transfer, which takes in a from, a to, and a token ID, an approval, and an approval for all event. There's also a few necessary functions, such as the balance of, which takes in an address and then returns the number of NFTs that specific address owns of this smart contract. It takes in an owner of function, which takes in a token ID and then returns the address of the owner of that specific NFT. It has safe transfer from functions, which are similar to the transfer from functions, just send back some data as well. The transfer from, which is transferring the NFT from one address to another, similar to the safe transfer from. An approval, so the approval would be used for a delegated transfer of using or having another smart contract transfer the NFT out of your wallet and into another. And then the get approval and set approval and is approved for all just go along with that approve function, just to return whether or not the contract was actually approved and for how much. In this smart contract here, this was an NFT smart contract that I had created myself and actually deployed to the Polygon network. So what we do here in order to create your own NFT smart contract, first what you need to do is put in your license identifier, your Solidity version, and then import the Open Zeppelin ERC 721 URI storage, and then inherit that into your contract. Similar to how the ERC 721 standard is something that's been implemented across the board. So rather than reinvent the wheel, we're going to utilize an already proven and tested library. So once our NFT contract inherits from the ERC 721 URI storage, what this does is this takes in all of the functions and mappings that are included in the URI storage, as well as in the standard base ERC 721. Which this is where it takes in all of the required functions according to the ERC 721 standard found on the ethereum.org website. Here, as you can see, it takes in the approvals. You have your balance of, owner of, you've got your approve, get approved, set approved, is approved, your transfer, safe transfer. You have all of the necessary functions built right into the already tested and proven Open Zeppelin library. Next, for this contract, what I did is I created a token count, as I like to keep track of the total tokens minted, as well as set the deployer address, which is deployed in the which is set in the constructor, where deployer is equal to message.sender. And then I implemented a minting fee, which is 0.03 Ether, if I remember correctly. Now what this minting fee is that in order for someone to mint one of our NFTs, they have to pay this minting fee, obviously. Next, what we have our IPFS hash. So some smart contracts or NFTs, they store the token URI on the blockchain. But for majority of cases, the storage of images are actually too gas costly. So what we do is we store it on a decentralized file storage system called IPFS, or the interplanetary file system. So here, what we do is we store the IPFS hash for the metadata for the smart contracts or for the NFTs. Next, we implement a receive function so that the contract can receive Ether. And then we set the IPFS hash in the constructor, similar to when we set the deployer. Next, we have to implement a minting function. So this minting function is going to take in a require statement to ensure that the message.value, which is the Ether being sent over, is greater than or equal to the minting fee. Then we want to increment the token count. And then for gas reasons, we want to grab a local instance of local scoped instance of that token count variable. and then we take that token count and we mint message.sender with the current token. From there, what we do is we take the token URI and we encode it, the IPFS hash, the current token number, and then the .json. So what this actually does is this URI will point to a specific hash or node on the IPFS storage system, which will contain all the metadata for this specific NFT, which include the name, the contract, the attributes, as well as the image URL. The image URL is actually where OpenSea and other NFT marketplaces are able to pull the data and actually view what the actual NFT image is. From there, we set the token URI to the current token count, and then the token URI that we just created, which is the ABI encoded pack of the IPFS hash, and then the current token with a .json at the end. Next, we emit the minted event, which is declared right up here, which takes in an address to and in a uint token ID, and then we return the current token. Up next, what we want to do is we want to ensure that we can adjust the minting fee based on business need. So should the NFTs be sell too fast, we want to make sure we can increase the NFT cost or the minting cost. Or if they're not selling enough, we can reduce it down or even put it at 0. And then the final function within this NFT contract is a withdrawal funds. The withdrawal funds function is essential. This allows you to withdraw the ether that was transferred into this contract when they minted your NFTs. Without the withdrawal funds function, you'll actually run into a vulnerability, which the ether will essentially be trapped or stuck into the smart contract. As you can see, creating your own NFT contract is rather simple. Ultimately, what you need to do is import the ERC 721 library. Then you want to have your contract inherit it, set your IPFS hash, and then create a mint and withdraw function so that you can mint NFTs and withdraw the ether when it's sent to you. Thanks for staying to the end. Once again, my name is Anthony with the Blockchain Dojo. If you did learn something new, please like and subscribe, and stay tuned for more content.